your normal engine, maybe it's your diesel gen or whatever. If your diesel gen is making a very good, too much of noise, use what we call lubricants. There's what we call lubricant, or what the layman will call engine oil. Engine oil. All these two particular body, these two particular liquid, you understand, will definitely what? Reduce friction. That is, definitely reduce noise in your generator. Another one is to use a ball bearing where possible. Use your bearing where possible. Now the third point is you design bodies of faster movement, e.g. the front parts and bodies of a vehicle and aeroplane are streamlined to reduce friction. Someone will ask me, why do we have the aeroplane designed this way? Now, if your aircraft is designed this way, this particular body is what we call streamline or streamlinement, or whichever English you want to use for it. This body is streamlined so that when forces comes, as in where atmospheric forces, or will I use atmospheric forces? Wind, do you understand? Or what you call breeze. Now, when your aircraft is moving against wind, do you understand? There are some heavy wind that exists up there in the firmament that can actually break a glass. But that's why engineers, aeronautic engineers, decided to design aircraft this way, so that when those breeze force or forces of the breeze come in contact with it, they will easily wear off. Do you understand? They easily being pushed off. But if your aircraft is to be designed this way, you know that the pilot is in trouble, because the forces of those wind or breeze will have heavy concentration. That's what we call heavy concentration at this tip. And before you know it, one day to just break the glass. And in an aircraft, maybe the glass is broken. There's what we call attractive forces that will be bringing people out of the aircraft, and that is the end. So, those are the very good advantages of having a streamlined body of aircraft. Now, under friction, which we have actually dealt with, what are the activities involved? Identify the force acting on the following: a stretched rubber pan, we have a water well rope when fetching water, we have dragging a stubborn, as in when you are dragging a stubborn dog, we have a nail on a magnet, forces attached to it. Let's do a little recap. We spoke about two types of force. We have what we call the contact force, that is forces that exist when two bodies come in contact. But we also said we have what we call field force. Those field force don't need two bodies to come in contact. They naturally exist. They exist in the free air. They don't need two bodies to come in contact. And we said forces like that exhibit in force field. Field force, that's what we call force field. Now, fields that we have analyzed, we analyzed them. We talked about the electrical field, we talked about the magnetic field. So those two field forces exist. Do you understand? And forces that exist in that particular region, that particular phenomena, are not contact forces, but what? Field force. So those are what we discussed, and we went into little of what? Friction. And be able to explain what friction is, the advantages and the disadvantages. Now, let's go into another one. We have what we call vectors and scalars. That's what we call vectors and scalars. In science, these two phenomena has always been used, and some people get it confused. Now, here we are going to break down the two words, and we are going to break them down in terms of their actual meaning. Now, what is scalar? Let me start with scalar. When you say scalar, what does it actually mean? We have it spells this way, and we have your vector. Now, scalar is a what? Is a quantity that has only what? Magnitude. When I say magnitude, it has just its magnitude. Do you understand? When I say magnitude, I'm talking about the content. It only has a content that does not have what? Direction. It only has a content that does not have a particular what? A particular area of concentration. It's just with magnitude. You just say scalar is any particular what? Is any particular quantity that has only magnitude. While vector has both magnitude and what? And direction. Vector has a direction, but scalar has no direction. Scalar only does have the what? The magnitude, but no direction. Vector has both the magnitude and the direction. Now, examples of scalars. Examples of scalars, we have what we call the speed. Your speed. Say the speed of a man is so. Let's say the speed of a man is 10 km/h. If I did not show you the direction, will you know? No, you only know that it is a speed which you render. There is no that specific direction. Another one is your distance. All these are examples of scalar. Another one is temperature and mass. But when it comes to vector, we have what we call velocity. We have what we call velocity. We have what we call displacement. And we have what we call acceleration. All these quantity has specific direction with respect to their magnitude. Now, examples of vector, we have talked about the examples of scalar. Examples of vector, we said all the following measurements involve magnitude and direction. Now, let's look at this. If you have a direction like this, I've given you direction, and I'll say it's 10 meters per second east. If it's only this 10 meters per second that I gave you, it's just a magnitude. But because I put east, it now has direction, meaning that when you draw the Cartesian graph, I put the north, the south, the west, and the east. Which direction is this thing moving? 10 meters per second east. So on this particular axis, 10 meters per second. It now has a direction. For it to now have a direction, this particular phenomenon is a what? Is a vector. You understand? Now, I can also have something like this. Minus 9.8 meters per second. Meter per second squared. That's an acceleration. It has a direction downward. Do you understand? So those are the major representation of vectors. So let's proceed. Now let's go to what we call vector notation. Vector notation. We must know how to note vectors. Vectors notation can be this way. Can note a vector this way. A with a bar on it. You can also note vector this way. A with an arrow. And you can also note a vector with a bold letter. When I say bold letter, or let me use small letter, A with a bar with arrow. Do you understand? Then a bold A. If I have something like this, anywhere you see these three in science or in physics, you know we are talking about vector. That is how we note vectors. Now, examples of scalar, we have said that before. The examples we spoke about time, spoke about mass and the rest. So let's proceed. Now, under our chart, we have charts that consist of the scalars and vectors. Well, I think we've dealt with this before. The length symbol, the unit, the mass, the unit, the volume, the area, density. We also have the vector where we have the displacement, velocity, acceleration, momentum, and force. So now under our activity, you can differentiate. You must know how to differentiate. By now, you should be able to differentiate between scalars and vector. What are the two differences? Scalar has just the magnitude. Scalar is any quantity that has only magnitude, while your vector is any quantity that has both magnitude and direction. So let's proceed. Hello. The next topic on our list is speed and velocity. Speed and velocity. Now, at this juncture, we'll be looking at the differences between speed and velocity in terms of definition and some good, wonderful diagrams. So now, first of all, we're looking at the actual definition of speed. From our slide, you'll be able to discover that speed is the rate of rate of change of distance. Speed can be denoted by s, which is rate of change of distance per per time. The d here stands for the distance, while the t stands for the time. Distance is measured in either meter or kilometer, while your time is measured in either seconds, minutes, or hours, depending on whatever you are given. So whenever you see a notation by, if you see an alphabet S in physics, it denotes speed, and which is defined as this rate, the rate of change of distance with respect to time. Now, if we move ahead, we'll look at another parameter called uniform speed. We said the first one was just the definition of speed. But what does it mean to experience uniform speed? Or what is the actual meaning of uniform speed? Now, if the ratio of s to t is constant throughout the journey, the speed v is uniform. What are they trying to say? The ratio of what? D to t, that's your distance to time, is actually constant. What do I mean? If you have your vehicle now, the vehicle is actually moving at a particular speed. Now, if it does not, you know, the vehicle is moving from, let's say, from A to B. Now, this vehicle is moving. Now, it's maintaining a particular what? Speed limit. You know, if, let's go back to a vehicle now. Now, there's what we call, a particular place in the vehicle called the dashboard. Now, on the dashboard, we have what we call your speedometer. If you are very conversant with vehicles, you realize that your vehicles have what we call speedometer. Now, it starts from, let's say, 20, you see something like 20, 40, 60, 80, 100, and so on. Now, immediately immediately you check your speedometer and realize that the indicator is moving upward. Now, when it gets to this 100, you realize that that vehicle is really on a very high speed. Now, what do you mean by uniform speed? Uniform speed is when a particular vehicle is moving from a point A to point B, maintaining a particular point, that's a particular speed, for a minimum time of, let's say, 5 minutes or 10 minutes. You understand? A vehicle that is moving now, within that 10 minutes, is maintaining this speed of 40. Let's say, for instance, is maintaining 40 kilometer per hour. You understand? It's maintaining 40 kilometer per hour or 40 meter per second. Now, this particular constant speed is what we call uniform speed. Now, from that word, uniform speed is a phenomenon whereby a particular vehicle, a particular body, which is moving from one point to another point, maintaining, do you understand? The phenomenon whereby a particular body maintains a particular speed. Do you understand? With a known or with a specific period of time. With the two, when you have two different time range, let's say from 5 to 10 or from 5 to 20 minutes, that speed doesn't change. That particular speed point is what we call uniform speed. So it's a very